you are coming in to the house from this section, this door here, you must be able to control the main light inside your kitchen. And the main light inside your kitchen, in this case, would be the fluorescent light. The recessed light would be your secondary lighting. All right, and then you also would place another switch here to control if you have a light that's over the door opening at the back of the building. So you may have a light here, you just control that from here. Okay, so that takes care of your kitchen and your bathroom. Now this long hallway here, you obviously would need, and the thing about it too is that if you, it doesn't matter the amount of bathrooms you have, the same setup will be needed in all the bathrooms. The same thing with the bedrooms, the basic setup in the bedroom, the fan with the light, and you put your duplex receptacles on the wall, right? Only that your master bedroom, you may want to add a few more things to it based on the electrical plan symbol. Now, importantly, you want to place inside of your hallway, you'll want to place this main distribution panel. The main distribution panel or the breaker box must be readily accessible, meaning it must be in a point at a point in the house where you can reach it at all times. It is not blocked or covered by any furniture or anything, because that is your main safety device. It must also be at a point that is close enough to the point of entry of where your supply is entering your property. So for example, if the utility pole, if you're taking if you're getting access from VPL and the utility pole is on this side of the property here, that has the transformer that steps down the voltage and sends it into your place. So from this utility pole here is where you're getting your supply. It simply means that on this wall here, right here, would be your service where the, sorry, this wouldn't come from this point, that'll come from the transformer. So this is where your service wires, the 3 wires would enter your property, 2 black and a white. And this is where your disconnect switch would be. Okay? So it means therefore that your circuit breaker, which would be the next point on your delivery system, would be here on this wall and not on this wall over here. Okay? So you will come from your disconnect switch here, send the wires over to your main distribution panel here. So you would send those wires overhead, and that would be reasonable. Now, the only way your breaker panel would be on this side would be if this setup here, was actually over here. Is that clear, everyone?
Yeah.
So based on where your supply is coming from, that determines where your main breaker panel is. So your main breaker panel would be there. This is a long passage, so you might consider placing two lights in here, one here and one down here. And obviously, you will have to have a three-way switch at the start. I will put it here of your hallway here, and one down at the end of the hallway somewhere down here. And both lights would be joined together in that system. All right. So again, let's review before we move on to another question. This is 16 points. You have to ensure that you put details inside each room. So you go specifically room to room. Key features that you need in your bathroom and your kitchen, and if there's a laundry room, are ground fault circuit interrupters, and you'll add an AFCI behind the fridge inside the kitchen, as well as a range outlet behind your stove. If you have a passage or a hallway, you ensure that you put a lamp inside that, controlled by a three-way switch. Switches must be placed in the door openings and not behind the door. Duplex receptacles must be placed 6 feet apart, one on each wall in a room. All right. Special rooms like for example, this study that you see this building have. If you encounter a question with a study inside it, you will put things like your telephone outlet, your TV outlet inside there, so that you have that, and then you could use fluorescent lighting inside it, or recessed lighting, or a combination of both. You do not need to put the HVAC or the AC or heating wiring diagrams on this to get your 16 marks. No, you don't. You just need basic stuff: your fan, your light, your switches, and your duplex. Then you put your main distribution panel inside an accessible area in your house, and the most accessible area is usually in a hallway. So that takes care of that. That's 16 points to basically put the circuit down inside this um inside this first question. And for the life of me, I can't see how people would miss this question. It's the very first question on the paper, and it is worth the most on the paper. This question determines whether you pass or you fail the entire exam. All right, good. Any questions? No questions. All right, good. Now, the follow-up question on the next page you will see in a minute will ask you to calculate the floor area for this building. As you can see, this is a complete rectangle. Therefore, all of this space inside here is referred to as living space. All of this interior space, because you have interior wall and you have exterior wall. And the wall is determined by the size or the width of the blocks that are used to construct this building. So the width of the blocks can be 6 inches or 8 inches. Now, all of this space here, as I'm saying, is known as living area, which means now that you need to work out the amount of power needed to supply this area correctly. Because if you don't have the right amount of power supplied to this living space, you will have low voltage, low or no voltage in some areas. And the reason you will have that is because you did not properly work out the power rating needed for this building. The National Electric Code NEC, which is the governing body for electrical work or electrical standards globally, stipulates that for every square foot, you must have 3 voltage amperes. Now that 3 voltage ampere per square foot means that if you should take one tile inside your house, a tile is 1 foot squared. So for every tile space in your house, you must have 3 voltage amperes. So if you should now quickly take a look at the room you're in, if you can see from one wall to the next wall, and you're able to count the amount of tiles across in one direction, that would be the length of your room. Then you count the amount of tiles in the next direction, that would be the width of your room. Then to calculate floor area, you need length times width. Right? So when you come up with your floor area, your answer is given in square feet, because your measurements must be given in feet. And if you get inches, you will convert your inches into fractions of a foot. Now, as you will notice on this diagram is this scale. Now, a scale is a system that is used to reduce objects into drawing space. The architect's scale is a 1/4 inch to 1 foot, which means that for every 1/4 inch that is measured in paper space, it is equivalent to 1 foot in real life or on the ground. So basically, this building was condensed to a scale of a 1/4 inch to 1 foot. Now you would take your scale ruler and you would measure the width of the building, or in some case, some persons would say the widest width and the longest length. And say when you measure it, you would have gotten, for your length here, you would have gotten 38. Let's go bigger than that. Let's see. All right, let's say we got 45 feet, 9 inches. And then down here, when we measured it, we got 28. You got 28 feet, 6 inches. All right. We now need to calculate the floor area. So we'll say now FA is equal to length times